So when you're loading a electronic data file, an ASCII file into Python, the main function comes from the pandas library. So you always want to import pandas as PD. We always use PD as the acronym for pandas. I don't know why, but it's a nice little abbreviation. Um, so PD dot read underscore CSV. That's our main function here. Now it's got a whole bunch of parameters, and we're going to go over these parameters one by one and talk about what kinds of problems they solve. These are tools, right? You're not always going to need to use them, but they sure are handy if you need them. Please look at the notebook for examples of messy data and how to deal with that messy data using the following parameters. So the first parameter is just called file path or buffer. It's a string, so words, and it's one of three things. It's either the full file address and the file name of the file you're trying to load, or it's just the name if you've already set the working directory to the folder where your data file exists, or it's the full URL of a data file that is accessible online. Okay, so that's the first thing. And as we saw in the simple example in the last video, sometimes it's all you need, right? I'll skip this slide and come here. Now, if you have an extraordinary situation, something a bit out of the ordinary here, then you could use sep, you could use header. Okay, let's talk about sep first. Another name for this parameter is delimiter. This is also a string. This is where you could specify the symbol that is used to separate one data point from the next. So it is a comma by default, but if you have tab delimited data, for example, you have to write sep equals and then a slash and a t. That slash and a t is how Python understands a tab. Okay. If you want semicolon, if you have semicolon delimited data, then you would use sep in quotes semicolon. Header tells Python where to look for the variable names or feature names in your data frame. The default is header equals 0, in which case it's going to use the first row for all of your column names. Okay? If header equals none, then Python will assume that there are no variable names and that the first row is just data. So that is important. If you have an electronic data file with no column names embedded in it, then the default, it's going to take the first case and use that first case, the data points themselves, as your column names. Not only does that give you bad column names, but that's wasteful. You lose a observation of data that way. So header equal none is the safe way to do it. And then you can use a prefix like prefix equal x, and then it will give you x0, x1, x2 for all of your features. And so again, there's an example of that in the notebook. Header equal j, that uses the jth row. So suppose that the header doesn't begin until row 7 for whatever reason, and that the first 6 rows are covered by copyright information or something like that. Then you could write header equals 7 and then pull the feature names out of the 7th row. Okay, use calls. Use that parameter only if you want some of the columns to be loaded from the outset. So this is really useful for data frames with a huge feature space, and you only need a few of those features. This is a good way to save yourself a lot of time so that you don't need to load the entire thing and wait for it to load the entire thing. So if you wrote use calls 0, 3, and 5, it would load the first and the fourth and the 6th columns. Now remember that the Pythonic way of counting always starts at 0, right? Like, what did the Python users sing at the baseball game? For it's 0, 1, 2 strikes, you're out, right? Okay, so 0, 3, and 5 loads the first, fourth, and 6th columns, okay? You could also give the column name, so you could get the case ID, whether they voted in 2012, whether they went to a political meeting, by giving the 3 column names, okay? In general, I don't like using this parameter because a lot of the data sets I work with in political data aren't that big in the feature space, so it doesn't hurt to load the entire thing and then deal with the columns a bit more deliberately later. But this is a good option if you only need a few of the columns. Skip rows, it's similar to use columns. It tells you what rows to skip instead of a way to skip columns, right? So skip rows 3, that will skip the first 3 rows of data. And if the header is left as its default, it means that the 4th row is assumed to contain your feature names. Skip rows list 035 will skip the 1st row, the 4th row, and the 6th row for whatever reason. Skip footer is the same as skip rows, but it counts from the bottom, right? So skip footer 035 would skip the last, the 4th from last, and 6th from last row. N rows only loads the first several rows as specified by the user. So if you say n rows 100, it'll load the first 100 rows and then that's it. NA values. This one is one of the most useful. Sometimes data authors use a code other than NA to indicate a missing value. So in the American National Election Study, they used -7 to mean don't know, and -8 to mean this person refused to answer the question, and -9 to mean this wasn't applicable to that person, and then 998 to be I've never even heard of this person. So these are all different missing codes. I want to replace them all with a Python recognized missing character, right? NA is actually an R thing, and in Python would be NAN, but you get the idea. If you want to replace all of them with missing codes across the entire data frame, NA values -7, -8, -9, 998, just like that. Okay? Now, be cautious, because if there are any valid data points that are -7 or 998, you'd be deleting those. And it's always a bad idea to get rid of data that is valid and that you could use. So just be careful that every -7 is a missing value everywhere.